This is Shakil Ahmed. In this tutorial, we will discuss about Naive Bayes Classifier. Naive Bayes Classifier is used Bayesian theorem, Bayes theorem that includes the conditional probabilities, basically the predicting the outcome given axis based on the prior distribution. So Naive Bayes is simple yet effective classification algorithm based on Bayes theorem. It assumes that the features are independent, although it's not possible in many real-world situations, but we assume that they are independent. These new assumption simplifies calculation and make its working efficient and quick. It is mostly used for classifying text and spam of emails, whether they are spam or not, based on the text. So, although we can use Naive Bayes classifier for other classification tasks. So in this tutorial, we will just see how we can implement a Naive Bayes classifier for predicting health outcomes. We have Framingham heart disease data set that consists of 10-year chronic heart disease status, whether the patient has heart disease or not, with some demographic and clinical characteristics. So we start with importing data from Google Drive, as I have already imported here as a Birmingham CSV, and then for reading the data from CSV we need to import pandas as PD, and then PD dot read CSV, and then the data set in CSV, and you can download the data from this download link. So I have already the data set. You can just check for the missing values and other things, but before going to that, we need to import required libraries. We need pandas as PD. We have already imported here. You don't need again, and the numpy is np, and then test the training test separate from sklearn model selection, and then sklearn nav or sklearn we need, we just import Naive Bayes as Gaussian Naive Bayes, Gaussian NB, and this assumes the Gaussian distribution, normal distribution for the outcome, and then sklearn matrix, we import accuracy, confusion matrix, and other things like F1 score. We can also see different performance measures, and then for visualization we need matplot library and seaborn. Now we will display the first few observations as we already done, and we can see the types of variables using df.info. This will tell us uh, types of different variable. For example, male is a integer 64. It means it is a characteristic or a qualitative variable rather than a quantitative variable, and the floats are mainly the quantitative variables. For example, systolic blood pressure, diastolic blood pressure, BMI, heart rate, and glucose level. Here we need to import the data set. We are just imputing the data sets with missing values with their mean. So you can just do df fill NA, then data frame mean means for all the observations, you are just imputing by their means within the column. And although you could separate the data into categorical and quantitative, variables, and then you can impute the quantitative variables by their means and the qualitative variables by their modes. But I'm just skipping this step, as we have already videos on handling for missing data. You can watch them as well. And then you can we can split data into dependent and independent variables. The independent variables are all other features, excluding all other variables excluding the response variable, and the response variable are the dependent variable is 10-year chronic heart disease status. And then we are going to split the data into test and training. So we have four parts: X train, X test, Y train, Y test, and then train test split function, and give your input X and Y, and then test site that size that is 20%. It means we are keeping 20% in our test set. And then the random start is 42. You can write any number here. This is just a random selection, random splitting of the data into test and training. And you can just use this, print this to or check whether your code has been executed or not. This code is executed. Now we will train our model. So the model, we can just name some name to your model as model. And here we have Gaussian NB, as we have already specified here. You can see the Gaussian NB. So this is the function basically we are using, just like random forest classifier and other functions. In a Naive Bayes classifier, we use Gaussian NB. Just we named it as Gaussian NB, and then model dot fit, then inputs X train and Y train, and then you can see the predicted values. You can also print the Y predict. Let's run this so you can see the predicted values of Y. Now it seems that the Naive Bayes classifier is predicting more values as CHD as opposed to other methods we discussed. So let's see how it will give the accuracy and precision. Now we can just evaluate the accuracy using accuracy underscore score, and then Y test and Y prediction, and just print this accuracy. So accuracy is 0.83. It's mostly equivalent to other methods. Now we can check for the confusion matrix. So here we can see 21 cases with CHD has been predicted as CHD, and 686 cases non-CHD have been predicted as non-CHD. So we will discuss this further in through heat map. We can just make a heat map, plot the figure size, and then confusion matrix as you have already obtained, and then annotation, and then FMT, and color map that is blue, and these are ticks, x-axis ticks and y-axis ticks, and then x-axis label and y-axis label, and then overall table. So you can see your plot, and you can see the confusion matrix. So this is confusion matrix. You can see these are the predicted values and these are the actual values. So how many no CHD have been categorized or predicted as non-CHD? That is 686 and 21 CHD. Here you can see the precision is 87%, and For the non-CHD group, here it is 0.35%. In previous, we have already uh, seen that for most of the method, the precision was very low, as the predicting the CHD cases were very low. For example, 8, 9, 10 observations cases were predicted as CHD among the CHDs. So it's also giving a good value of recall for the two groups and F1 score as well. And it's now you can just you have an average, a good average number of average precision, recall, and F1 score. So this method is performing very better than the previous method. So we can always prefer the Naive Bayes classifier on other machine learning methods for predicting the categorical outcomes. And then we can see the variable importance uh, from sklearn inspection. Import permutation importance. We need to import this permutation importance. Then permutation importance is a function, and then use the model as you have named the model above. And we are using X test set and Y test set and repeat it for 10 times. And then we based on the basically prediction performance, we see which variable is most important in predicting the CHD. And then we sort ID of X based on performance, permutation importance, and then importance mean dot argument sort. It means we are just we are getting the sorted importance values, and then we will just X columns according to the sorted indexes. It will take We will take it on x-axis, and on y-axis we will keep the mean permutation importance value. And then we will label x-axis and y-axis and see. So this is the feature importance we get through Naive Bayes classifier. You can see the blood pressure is the most important variable in predicting chronic heart disease, then glucose, and then diabetes, and then prevalent stroke and other variables. Age is least important. Smoker after smoker. So although you can see the importance of age is going on negative side. So this is all about the Naive Bayes classifier. So before implementing it in Python, you need to know about the theory of Naive Bayes classifier. I have discussed the implementation in Python. Thank you.